Hello, back to Energy 101, and today we're going to talk about electric car carbon emissions. In my introduction or somewhere on my main page for this course, I made the statement that electric cars do not save carbon emissions. I put that on there to be controversial, and it certainly did create a lot of controversy. It got more comments than almost any other topic, which was good. And that's what I meant for it to be. And it is a controversial statement. But the reason that I put that up there and the reason I addressed this is I was always amazed that electric car manufacturers, this happens to be a photo of a Leaf, it got emblems on it that says zero emissions. And I felt like that might be a little misleading. But zero, I feel, is misleading. Now, it does have zero tailpipe emissions because it doesn't have a tailpipe, no question. But let's drill a little deeper and see if when you buy an electric car, if you really, when you drive it, are you really producing zero carbon emissions? And like I said, I'm taking a particular case, and you can debate the zero statement. You can always come up with a scenario in which a zero is true. But let's look at the one that I feel like is the appropriate one from a public policy viewpoint. When you look at it from an individual viewpoint, it can be different. But the question, do all electric cars have zero emissions? View from the U.S. Or do they reduce emissions is probably a more nuanced question. It definitely is a more nuanced question. But I want to take the view from a U.S. public policy viewpoint, not from a personal or regional viewpoint. So when I say public policy, how much do current tax incentives that put more electric cars on the road throughout the U.S., all over the U.S., reduce CO2 for the U.S.? Because it's an international problem, so emissions that are produced in California affect New York and Florida and vice versa. So it's we need to look at it from an energy policy and global warming policy viewpoint from a national perspective. So not from an individual or regional perspective. You can get a different answer if you look at a personal situation where if you're off the grid, for instance, and getting all your electricity from solar or wind, the answer is you're damn close to zero, okay? No question about that. Nobody can debate that, I don't think, if you're off the grid getting it from renewable energy. But that's not the typical situation. I would contend is, I hadn't run the numbers, but it's probably less than 1/10 of 1%. And 99.9% are going to get it from the grid. So let's try to answer that question. Well, number one, we have to look at where does the electric car energy come from? And when you plug it in to recharge it, and it gets no energy from gasoline. You don't have a gasoline tank. Now we're talking about all electric cars here, ones that run totally on electricity like the Leaf. The Leaf is I keep using that example because that's the first really mass-produced electric car by a major international car manufacturer such as Nissan, as the Leaf is. But all the energy comes from the electric grid. None of it comes from electricity. The Chevy plug-in hybrid, as we talked about, is different. It gets some from gasoline, some from the electric grid. The Prius that is strictly a hybrid that's been out for 10 years, it gets all of its electricity from gasoline. We'll talk about that. But the electricity generated for charging the batteries does create CO2 at the electrical power plant. In general, when you're looking at the grid as a whole, some of that electricity going into that grid has been generated by fossil fuels that emit CO2. So let's dive a little deeper into this and see how we can calculate this number. We've got to make assumptions along the way, and you can change the number with different assumptions. So it's a great question for discussion and a calculation for discussion that depends on the assumptions. So I'm giving you my assumptions here, hopefully. But how much, if we want to look at how many kilowatt hours are required to drive the electric car 1 mile, that's the first thing we need. We need to know how much electricity has to be generated and put into the grid due to the fact that we now just bought an electric car, or bought 1 million of them, and put them on the grid. Well, the Leaf, according to US EPA, it's like fuel mileage that they quote, uses about 1/3 of a kilowatt hour per mile. 1/3 of a kilowatt hour per mile. And that inverted means it gets about 3 miles for every kilowatt hour used. 3 miles for every kilowatt hour used. So somewhere, so when you generate a kilowatt hour, it'll drive you approximately 3 miles. And by the way, these kind of calculations, you can debate plus or minus 10% on any of these numbers. You can debate plus or minus 20%. So I try to stay out of the fractions and decimal points and those kind of things, because we're trying to look at the big picture and reach a big policy decision question here. But the next thing, the next thing we need to know is how much CO2 is emitted for each of those kilowatt hours that is generated and put into the grid for that battery to be charged in our electric car. Well, if you take the total CO2 emissions and the carbon emissions from power plants, all power plants, and that you get that number, I got that number from EIA, Energy Information Agency, off the web, then divide it by the total U.S. kilowatt hours delivered, then that gives you pounds or grams of CO2 per kilowatt hour produced and put into the grid. And by the way, the number comes out to about 1.2, approximately 1.2, 1.12, 1.3, 1.23, 1.818 is in that ballpark. Which, by the way, is 545 grams per kilowatt hour. So that means then that the pounds of CO2 produced per mile driven in your all-electric car that gets 1/3 gets 3 miles per kilowatt hour, such as the Leaf, is 1.2 pounds divided by 3 miles per kilowatt hour, or 0.4. So you got about, the electric car on the Leaf type will get about 0.4, or produce about 0.4 pounds of CO2 at the power plant to generate the electricity to carry the car 1 mile. Now, that's a sum total of the CO2 produced by all the power plants that feed into the grid that you're charging the battery off of. Now, we need to look at the gasoline driven so we can compare it. What's the gasoline driven car CO2 emissions? Well, you can look it up again on Energy Information Agency, which is where 90 or 98% of my data comes from. It's a very dependable source, and it comes out to about 19.6 pounds of CO2 per gallon of fuel burned. 19.6 pounds per gallon of fuel burned. It's kind of interesting. A gallon of fuel weighs only about 6 pounds, but it produces 19.5 pounds of CO2. And of course, the reason for that is that the gasoline is made up of carbon and hydrogen, and then you take the oxygen out of the air, and that oxygen reacts with the hydrogen, so now you've added the oxygen to the carbon, and that mass is higher than the original carbon and hydrogen that we used to begin with. But now, if you know the miles per gallon that car gets, then we can calculate the CO2 emitted per mile driven by the gasoline car. And so if you just take 19.6 pounds of CO2 per gallon and divide it by the miles per gallon of that particular car. So in order to get equivalent, you can play around with it and calculate it exactly. But essentially, if you take a Prius hybrid that runs totally on gasoline, it generates some electricity for itself when it charges some small batteries when you come to a stop due to braking, and uses it back when you start back up, but it gets no electricity external from the car at all. it gets all its energy to drive from gasoline. And you come up with about 0.4 pounds per mile. Well, obviously, you got to use the 50 because it's about equivalent to the Leaf, to the electric car. And and they're similar size cars, similar performance. There's not a heck of a lot of, I don't think a person shopping for a Leaf is going to be also considering a GMC Yukon or something, in a big SUV. So you gotta compare apples to apples here, I think, to have a rational number in my mind. So is U.S. the next question though to ask, is the U.S. average CO2 emitted per kilowatt hour the proper value to use? That I came up with the 1.2, remember. I just took the total CO2 produced by all power plants and divided by the total kilowatt hours produced by all power plants. Well, I claim that that's probably not the right value because it's too low due to dispatching issues. An electric car is mostly charged overnight, and there's lots of excess power capacity at night, by the way. And some people argue we got to build more power plants to meet the charging need for all these electric cars, but that's not true, since most of them are going to be charged at night, and we have low demand at night, and there's plenty of power plant capacity to meet the increased charging demand from these new electric cars that we're putting on. But the incremental electricity will not come from renewables is one strong argument that you can make, because they're already being utilized 100%. So when you put an incremental load of one electric car or 1 million electric cars onto the grid, you're not going to get any more electricity from renewables because you're using all that anyway. The economics demand it, the real operation demands it. You just don't turn off wind turbines. You take the electricity anytime you can get it, same way with photovoltaic and power towers and all that. So it's a dispatching issue. So I claim that you can argue strongly that you're going to have to use and do use the fossil fuel coal and gas plants, which are the last ones that you turn on and off to meet the incremental demand in order to meet the increased demand due to the electric cars that need to be charged. That's certainly a debatable position, and I think it's a position that you can defend. So the conclusion on this, and again, I'm looking at it from the U.S. policy viewpoint, not for an individual situation or an off-grid situation. But number one, I certainly think that it's a little unrealistic to talk about electric cars have zero emissions. And I really don't think that statement in general is true, and I think it leads to some misconception. It's true if you view it just from a tailpipe situation, and if you view it from a isolated situation where you got solar equipment just serving a electric car charging itself, but that's a pretty dumb application for solar because it's sitting there not being used unless you're charging the car. But anyway, I'll let you debate that. The CO2 per mile then depends on the dispatching issue. So and by the way, if you just look at the CO2 emitted from incrementally cranking up the non-renewable, non-nuclear power plants, you get about 1.7 pounds of CO2 per kilowatt hour produced, not the 1.2 that I used in the example to get 50 miles per hour. Well, when you use the 1.7, assuming that the electricity is going to come from, because of dispatch reasons, from the coal and gas power plants, you come up with about 35 miles per gallon. So I believe that there's no black and white answer to this, and you can change your assumptions to get different answers, but I believe that the range of 35 to 50 in my mind is a pretty good range to look at and consider that the CO2 emissions from an electric car getting, like the Leaf, getting a third of a kilowatt per mile will produce. Now, as I said, you can make your own assumptions and limitations and look at different scenarios and come up with different answers. And you can look at where we might be 20 years from now or 40 years from now, but I think this applies for those being put on today. And it helps us to make some decisions about what we need to do with our power plant fleet that is feeding into the grid. If we want to do something about CO2, we need to deal with this issue. But electric cars are good, by the way, from the oil savings, because they definitely save oil. And we need them for that reason alone. And they certainly don't seem to produce any more significant CO2 emissions, but I'm not sure how much it'll help us on the CO2 emissions. You can make up your own mind. I tried to equip you in this course for looking at the facts and then using the facts to analyze your questions and come to your own decisions. So thank you for listening, and hopefully that'll generate some more discussion. Thank you.